So it is equivalent to learning all three now. But we also verified. Can communicate between them. It doesn't work with it. That's the same reason. It definitely doesn't work with 10.2. Because they cross VLAN. So this is what we call access. This is how it works. Everyone observe this MAC address table. The MAC address table I drew for you just now is relatively small. In fact, each of the MAC address tables is very useful. I just drew the interface and MAC address. It actually has VLAN. That is, how do I know which interface belongs to which VLAN? The MAC address table has. When you divide the interface into a VLAN, the VLAN corresponding to this interface will be written here in the MAC address table. So now a broadcast packet is sent from interface 01. I will only flood from other interfaces belonging to VLAN 10. So I can know. The data only goes out through the 01 interface. So this information is known by the switch itself. Because when it queries the MAC address table, in addition to looking at the interface and MAC address, it also looks at the VLAN. Dynamic means that the current MAC address is dynamically learned. Dynamic learning means that others send data to flow through it. In the future, you can also learn static binding. You will learn in NP. Let's do some port security. For example, a fixed MAC is connected under one port. Or we can also set up to connect multiple fixed MACs. If you connect a switch, there are many MACs below. It's okay too. Bindings also have dynamic bindings. You can also bind manually. This is all the content in NP. Now do a simple understanding. Let's talk about the process. If PC1 cannot access PC3 now, why doesn't it work? Let's review. PC1 accesses PC3. Then first PC1 thinks that PC3 is on the same network segment as it. Then send an ARP request. A broadcast packet goes here. Tag with VLAN 10. Then query the local MAC address table. Because it is a broadcast packet, so it should be on all interfaces belonging to VLAN 10. In addition to the receiving port. Flooding on other ports. Only this interface is issued. After receiving this interface. After reading the second floor. We need to look at the ARP in the 2.5 layer. There is a target IP inside. The target IP is to find PC3. But it's 10.2. So it won't reply. So PC1 cannot receive a reply. Because its request message can't reach PC3 at all. So it has no way to communicate with PC3. This is the basic forwarding principle of switches based on VLAN. Next we talk about trunk. If you are interested, you can make this kind of picture after class. This diagram is more basic. When we make a trunk, we directly make a more difficult one. We do one-arm routing. Trunk is the two switches. The difference between trunk mode and access mode is that, first of all, they have different names. It's obvious. Trunk means the main road through which more traffic will flow in the future. In the access mode, it is directly connected to the terminal. Then only terminal traffic will pass through this line. The trunk road is all based on the, like the picture in the courseware. Let me explain their names. Access link means this link is called an access link. This link will only run data belonging to the PC. Whether someone else accesses it, or is it accessing someone else's. This is actually equivalent to an access device. Trunk means now you don't care whether these two devices communicate with each other. The two devices communicate with each other. Or do these two devices communicate with each other? They all flow through the road in the middle. It's like what we call the main road. Now devices want to communicate with each other through it. The interconnection between each other is the same. This is also the trunk. We can also configure it as a trunk. So for us, where data flows through, it is equivalent to a trunk between switches and switches. The connection between the switch and the terminal is an access link. Only run your own traffic. So this is the difference in their names. Let's talk about trunk mode. Simply put, switch to switch. Here's what we call the difference between them. The biggest feature of trunk is it can host multiple VLANs. An access interface can only belong to one VLAN. The trunk can serve multiple VLANs. For example, now this is still a PC. Here is also a PC. PCs are connected to the interface of the switch. Also connected between the switch and the switch. A link used in the middle is called trunk. We connect to the terminal or access. For example, this is still access VLAN 10. Suppose the right side is still VLAN 10. Let's see how it goes. It's easy here. Let's not talk. Data comes in and hits here. There is another package in the trunk. Will be slightly different. We go in here first. Because what we use now is actually the same. After you come in, we will put tag 10 here. Then this data flows through other interfaces. For example, it is going to access this device now. Then the data will now go to this interface. When the trunk is sending data, there will be a difference. First, the trunk will have a release list. For Cisco, it will allow all VLANs by default. But please note, this allows all VLANs. It just means that the VLAN created on this switch will be released now. Assume that there is no VLAN 10 on this switch itself. Then the traffic of this VLAN 10 cannot pass through this interface. You must first create. You just create. It allows by default. Second, we will now check. Check whether this tag 10 is the same as this native VLAN. It defaults to VLAN 1. So now there is a VLAN 10 coming over. It checks whether it is the same as its own one. If the same, it will strip the tag. Send later. If different, do not strip the tag and send it directly. So now I don't modify it. Then come in is 10. If it is 1, send it directly. So actually, we are in the process of data transfer. It was sent back with tag 10. Then this data carries this tag. It came to the interface on the right. The right interface is also a trunk interface. Then when the trunk interface receives data, it will also have some processing behavior of its own. Handling behavior is simple. The first is to look at your release list. Also released all. So, when the data comes, it will receive it directly by default. But still that sentence, VLAN 10 must also be created on this device. Secondly, when we receive the data now, if the received data is received with tag, it just sees if it lets it go. If it is a raw data, that is, blank data frame, without tag, it will mark the native VLAN of this interface. Then you can send data, which is equivalent to, the ones coming in now are carrying tag 10. So I took it directly. After receiving this data, continue to move forward. Go to this interface now. Since it is also an access interface, and is VLAN 10. Then here it will strip the tag of VLAN 10 to complete the forwarding. Send to another PC. Then in this process, if there are some other circumstances, for example, now this interface belongs to VLAN 20. There is no interface belonging to VLAN 10 on this switch. But I created VLAN 10. The data will come in. But it can't reach the destination. Because cross VLAN. What we are talking about is that if they are different VLAN, it sure doesn't work. But it's okay to send the data like this. It's just that it can't be sent from this interface. This is what we call a trunk. Let's talk about its configuration in a while. This is how it forwards.